fine. Yeah. Ready to go?
Yes.
Okay.
Please start.
Thank you.
Okay. For the benefit of people here and on Zoom, we are having a talk by Roger Anderson about Einstein 1905 relativity theory, which was changed into a different theory. Please, Roger, start.
Okay. Thank you. Thank you for allowing me to do this talk, and thanks for organising this conference. So that's the title of the talk. So this is a continuation from what I was saying last year, and the thesis is that Einstein published his paper on special relativity in 1905 in German. He becomes famous in 1919, and that was when the decision was made to translate his theory of special relativity from German into English. So what you have is a 15-year period between that and 1905 when it's translated into English. So the English translation is not a faithful translation into English. Instead, it's been updated with the work that has been done on relativity in those 15 plus years, which amounts to the English translation is a different theory to what the theory was in the original German. And they don't seem to mention this anywhere. When you're studying relativity, they don't seem to mention that the theory's been changed from what it was originally. So to my mind, that is moving the goalposts, and moving the goalpost is changing the rules of a game to stop the other person from trying to win. And so changing the theory without telling anybody they're changing the theory, that is, in my view, moving the goalposts. Einstein should have said something about the change being made, but he didn't. So that suggests to me that theory might not have been fully his theory, and it might have been a joint effort with probably his wife, and she was uncredited. So this is Einstein's first wife, and he was studying physics with her at the Zurich Polytechnic, and she apparently failed the course, but Einstein passed it. And I would have thought that she would have helped him with relativity theory, since she was up on physics. But I think it was in the era, it's a male domination of the world, and it might have seemed unnecessary to mention his wife. But from modern feminist point of view, is that men back then believed they had male privilege. A wife could do the work and the husband take the full credit without having to bother to mention he was assisted by his wife. So I'm going by information from this book by Roger Highfield and Paul Carter. They say about Einstein's first wife, and they say it was put forward by where it says there, and the English and the German edition was published in 1983. After the author's death, this book contains many fascinating hints, but relies heavily on hearsay. So the problem is most of the evidence for maybe it was Einstein's wife is also working on the theory. Well, most of it seems to be hearsay, and so the skeptics, or the critics, preferred to dismiss the idea that his wife was helping him. And this is more evidence on it. She said that this person was pointing out that Mileva had a role in relativity. Next. So we have claims and witnesses that Einstein's first wife was a collaborator with him on relativity, and that's often met with skepticism. However, there is another aspect to this. Highfield points out, and he points out one reason why these claims have gained currency is Einstein's own failure to provide a clear and consistent explanation of relativity's origins. Not only did his paper contain no references, but he contradicted himself in later accounts of the influences on his work. It remains unclear, for example, how much he was stimulated by the so-called Michelson-Morley experiment of 1887. So Einstein was unclear about details of his theory, which would be the case if the theory was not solely due to him. If Einstein didn't fully understand the theory, he was then allowing others to modify stroke change it because he had gaps with what he knew about the theory. It was a theory in development and not a fully formed and completed theory. There are articles pointing out this sort of thing about Einstein. This is the article. He points out that Einstein was a misogynist, and really that basically means that he thought he had male privilege, but it was common in that time era that he was in that men were not really treating women very nicely. It was sort of women were kind of like second-class citizens because they didn't have the vote. So most men in Einstein's era, from a modern feminist perspective, would probably be labelled misogynists. So really it's unfair to label him like that. But he gives a possible reason why he left his wife uncredited as co-author if she helped him. He did not think it was important. Now, Einstein's a hero, and he did many heroic things, stood up to Einstein, campaigned against the atom bomb after it was used and so forth, things like that. So he is a hero, but with all heroes, they have or seem to have clay feet, and that's pointing out there's some weakness with them. So it's not really fair pointing out, Einstein was a misogynist, when everybody in that kind of era, the men probably were. It was just a common way of being, and it's also, with most heroes, they're not perfect. So I want to pick up from this bit from Highfield. It's unclear, for example, how much he was stimulated by the so-called Michelson-Morley experiment of 1887. This tested the speed of light to see it was changed by the relative movement of the ether. That was the medium which basically carried light waves. It found that light had exactly the same speed in all conditions. A speech that Einstein gave in 1922 suggested this unaccountable result was his first route to relativity, but a letter he wrote a year before his death maintained it played no decisive role. So Einstein was contradicting himself. One moment he was thinking, yeah, the Michelson-Morley experiment led to his theory, and next time he was thinking about it saying, no, it didn't. There's no decisive rule. And the most important thing about that is to say whether special relativity was founded upon the results of an actual experiment. The alternative to this is that Einstein's theory was based instead upon thought experiments instead of an actual experiment. So this is what you say about Einstein's thought experiments as per Wikipedia. Points out as a hallmark of Einstein's career was his use of visualized thought experiments, and it was a fundamental tool for understanding physical issues and for elucidating his concepts to others. And the experiments took various diverse forms. Now, the most famous thought experiment is when Einstein imagined what would happen if he was travelling with the beam of light and looked into a mirror. So the issue becomes, was special relativity based on a thought experiment where he was considering travelling on a beam of light at the speed of light, or did he base it on an actual physical experiment, namely the Michelson-Morley experiment? So this is a paper by John Norton, when he's a history and philosophy of science, and he's sort of an expert on Einstein. And he points out this issue. He tells us, even today, this point needs emphasis. The Michelson-Morley experiment is fully compatible with an emission theory of light that contradicts the light postulate. So basically what he's been pointing out there is you can look at the Michelson-Morley experiment still based on believing Newtonian physics. So why was there a need to suddenly bring in this light postulate, which Einstein brought in to then form his special relativity theory? So we have this, oh sorry, I'm getting a phone call.
From Einstein's wife.
Hello. Sorry, I'm busy at the moment. Can you try me back in an hour? Okay, sorry, bye. No, she's not.
Something which occurred to me in Roger's article, it's a lack of, he claims that Einstein left the actual.
So sorry about that. I don't know many people, and suddenly somebody's phoned me. They're sort of like, they're worrying about my wife because she has problems, and she phones me when she has problems as well. This is why I wasn't able to get to ANPA this year at Liverpool. Anyway, so back to my talk. We have this transition. The Michelson-Morley experiment can be interpreted by Newtonian physics, but suddenly it's swapped over to be interpreted by special relativity. And that's kind of mysterious, I think. It's pretty difficult to understand why suddenly do that. So the transition would be occurring if had the theory based on a thought experiment, a sudden jump of inspiration to interpret an experiment a different way. Thus was special relativity based on a thought experiment or actual experiment. Thought experiment would be just interpret experiment in a different way. Actual experiment would be impetus for experiment to use a different theory. And Einstein does not help us decide whether this result from this Michelson-Morley experiment was the basis for relativity. As I pointed out, he gives two different answers. And so, as noted by Highfield, he's referring to an unaccountable result from the Michelson-Morley experiment. A speech that Einstein gave in 1922 suggested this unaccountable result was his first route to relativity, but a letter that he wrote a year before his death maintained that it played no decisive role. And so, i.e. saying based on Michelson-Morley experiment and then saying it's not. It is preferable that a new theory be based upon actual empirical evidence that prompts needing the change of theory, instead of being a mere change in interpretation of evidence. But Einstein does not help us to decide which it is. Highfield excuses on Einstein having bad memory upon the issue of the Michelson-Morley experiment, but is another indication. If it was not Einstein's bad memory, then it would have been that he was not sole author of the relativity, and there might be uncredited co-author, i.e. possibly his wife, might have known on things. There are, of course, other peculiarities in the origins of relativity. And Einstein seems to be flexible in his thinking, also suggests he didn't fully understand the theory he was presenting. He changed his mind a lot on theory, and example is from dealing with the Minkowski space-time. First of all, he thought that was a bad idea and changed his mind and thought it was okay. So what we have really is Einstein did not have a fully formed theory. Instead, he had a work in progress, and he was allowing others to change it because he wasn't sure himself about the theory. So moving on, I think this is related to the theory being changed when translated into English. Einstein wasn't sure enough about what theory was to point it out, or he had difficulty with English. So this is the usual translation into English of Einstein's 1905 paper on special relativity. And you can go to that website where it has it there. And it says at the end of the paper, the extra notes from the translator and so forth, it's based on the original 1905 German language paper and so forth. And it has footnotes added to it by the translator. And it changed a bit of the notation for the symbols used for the equations. And so that was the translation in the form 1923. That is after 1905. It took 18 years to get an English translation. Now, I got this reference from Arthur Miller, and he's I think, historian of physics, especially a special topic, Einstein, and he points out that the translations of Einstein from German into English are bad, and so he provides his own translation. So it's not just me saying that the English translation is a bad translation from the German. Others have looked into that issue as well. And Miller points out the footnotes in the translated paper come from Sommerfeld and were not in the original. And these were the footnotes added to Einstein's paper, and they're not in the original German. So I contend it's a bad translation, and the footnotes and so forth made it very different in the English to what it was originally in the German. I could talk of the translation as being a mistranslation, and the translation is really from Sommerfeld's perspective of what he believed about relativity. He had the translation adjusted to align with his footnotes. And this is Sommerfeld. He was a German theoretical physicist who pioneered developments in atomic and quantum physics. So that's what I'm pointing out. You have Einstein, 1905 paper in German that gets translated into English, and it's Sommerfeld's version of the theory. He's made the adjustment to make relativity believe what he wants it to believe. So Einstein's 1905 paper published in German, 15 plus years later translated into English, but in those 15 plus years the theory had not stayed static, i.e. not stayed unchanged. There was various people like Sommerfeld had been working on it. And so what we're often presented with is the illusion that Einstein's relativity was solely due to Einstein, but that is false. There were other people involved working on it, such as this Sommerfeld. So 15 years later, 15 plus years later, it gets translated in English with the bias of what the people like Sommerfeld, were now believing about relativity. And why did Einstein allow these other people to change the theory? And the answer seems to be, as I pointed out earlier, he didn't probably appreciate it, and if he's not the sole author, etc., he didn't properly understand the theory himself, and he was allowing others to modify it. In other words, Einstein was very flexible in the meaning of the theory, which maybe he would have been, if not the sole contributor to the theory, then he would not have had a proper grasp of what the theory was, so he was open to others telling him what the theory was. So it's back to Sommerfeld again. He was the one adding the footnotes to Einstein's relativity paper in English, and he was imposing that on the translation interpretation from what was in the original German paper. And this is a quote as an example from the translation of Einstein's paper with the footnote. So the translation is, let us take a system of coordinates in which the equations of Newtonian mechanics are all good, and you've got a footnote, and the footnote is i.e. to the first approximation, where you don't have that footnote in the original German. It's what Sommerfeld has added. Another glass of water. Based on discarding all of Sommerfeld's footnotes and his bias in how to translate the paper from German into English, there's nothing about it being a different theory to Newtonian physics. It's Sommerfeld imposing on it that it's a different theory. In the original 1905 paper, it's not stating it was an approximate, and that's what I can tend to be. In the original Newtonian mechanics holds good, and then there's no approximation. The 1905 paper is dealing with Newtonian mechanics, and there's no replacement of Newtonian mechanics by another theory. So now the relativity has split into two theories: the original paper and Sommerfeld's changed theory. Sommerfeld added the footnotes to change the theory, and the translation was biased to agree with his footnotes. So nowadays, when we talk about relativity, we talk of Newtonian physics as an approximation of special relativity. Especially, we say Newtonian physics is a good approximation of special relativity at low speeds, much less than the light speed in vacuum C. And that's not in the original. That's only what's been changed by the Sommerfeld translation. And so, especially in the context of Sommerfeld's theory, or his version of Einstein's relativity, we can get at the things like saying Lorentz transformations reduced to Galilean transformations at low speed. And mathematically, that actually turns out to be false, as this person points out in a paper in 2006. But that is a common interpretation of Einstein's relativity now, to think that Lorentz transformations reduced to Galilean transformations at low speed. And that's not in the original German paper of 1905. In the German paper, there is no mention of Galilean transformations. So mathematically, we have something different between the two theories. The claim that Lorentz transformations reduced to Galilean transformation, that was something that came after 1905. So I'm going by this book. It's Arthur Miller again, and he's pointing out that the Galilean transformations were named in 1911. First appeared in Frank and Routh's book or paper, and another book I got is claiming the Galilean transformations were named 1908. So there's no Galilean transformations in 1905 when Einstein is writing his paper. It's not something he's talking about. There's no mention of Galilean transformations in the original German. So these are the transformations. You've got the Lorentz-Einstein transformations, and you've got the Galilean transformations. That's what the maths looks like. Galilean transformations, named 1908 or 1911, depending on reference. And Einstein 1905 paper was dealing with Lorentz transformations, not Galilean transformations. Nothing was being said about how Galilean transformations connected to Lorentz transformations. So we have this timeline. 1905, Einstein special relativity paper in German dealing with Lorentz transformations. 1908 or 1911, Galilean transformations appear. Those working on relativity decide that Galilean transformations are part of Newtonian physics and not special relativity. And so they decide Lorentz transformations reduced to Galilean transformations at low speed, thus Newtonian physics only an approximation. In 1920s, Einstein's 1905 paper translated into English, but with a move in the goalposts, they now think Newtonian physics only an approximation. When special relativity is taught, usually the Galilean transformations are talked about first before the Lorentz transformations, and that gives the impression that the Galilean transformations came first, and then working on them came the Lorentz transformations. That is the complete reverse of what historically happened. The Lorentz transformations came first, and later came the Galilean transformations. And so the education system has been set up to give false impressions like this. Rather than explain the theoretical historical development accurately, the education establishment chooses the easy option of not explaining that history. So talking about Galilean transformations, saying that they don't work, and then saying there's a need for Lorentz transformations, it seems easy for them to do. That's an easy education route, but that's historically not what happened. The original German 1905 theory is not that Newtonian physics is an approximation at low speeds. Nothing about Lorentz transformations reduced to Galilean transformations at low speed. And this is what I mean by talking about moving the goalposts. The theory kept getting amended, and it was getting amended from a very early stage. When translating from German to English, it was amended. So I've dealt with special relativity. The demarcation between special relativity and Newtonian physics is false. In the original German paper, there is no such false demarcation. Now for general relativity, I think the innovation was to have curved space-time, and you can add curved space to Newton, as pointed out by papers such as this one, curving Newtonian space. So in that context, general relativity, what do you really need to think of general relativity as being different to Newtonian physics if you can use curved space in Newtonian physics? So based on that, to deal with curved space would just be a natural development of Newtonian physics to add curved space concept to it. So I'm getting to my conclusion. The path was along the lines Einstein's theory 1905 in German, no mention of it being a different theory to Newtonian physics. Einstein 1915 general relativity. Einstein 1919 becomes famous due to Eddington's astronomical observations. Impetus then to translate Einstein's papers from German into English. Einstein 1905 relativity paper translated into English but now with the changes of opinion that happened between 1905 and 1919. And so Einstein theory becomes a different theory to what it was in 1905. Einstein, very flexible in his thinking, allowing the theory to be changed, modified, or else didn't properly understand the theory because maybe it was not due solely to him. And that's not being pointed out when they're teaching you relativity, that Einstein in the original 1905 is saying different to what they're now going to teach you. I'm finished. That's the end of this talk. Thank you. If you want, sorry, if you wanted to go on to the maths, I got some maths here. Okay. Thank you. That's the end.
Yeah. Thank you. Thank you, Roger.
Thank you.
Can I just say something before anybody else comes?
Okay.
I think it might be that Einstein on purpose didn't finish the special relativity into perfection.
Yeah.
I have a reason to believe that, because I used to work with a Jesuit priest who was also professor in physics in German, and we were writing a paper. And I wanted it. No, Otto. No. It's still. We need to still finish that. And he said no. I said why? Oh, he said, I have the experience. I once wrote a perfect paper, but everything was perfect, and nobody commented on it. So if you want things to go forward, you have to leave things which are open for discussion, bigger or smaller. So I do believe, and actually, you know. All of us are scientists here. How often do you lose interest if you break into something new? You may want to do something else, so you think, okay, I've done enough, let others tamper with details. So that might have been the case, and we can only speculate here. What I think is interesting from your article, which is in the proceedings, Roger, is that Einstein used to be in the teaching circle of students, and they didn't seem to quote anybody, giving any references. Now, my personal experience with my students is, before the term plagiarism was known, it was probably going way back in science. So this is also not really surprising that he didn't quote many sources. People just didn't think it was important. Take something and rework it, and that it becomes yours. Yeah. Nowadays, we are much more sensitive to that, as you know. I mean, up to the point that people can sue you if they think you stole their theory. Yeah. So that was about what I wanted to say. Anybody else wants to comment?
Yeah, could I come on that? So yeah, sure. So Einstein was working in his environment, and we're not really sure what he was allowed to get away with, sort of like in that environment back then. I think you would have naturally not credited your wife as helping you if she did help you. And so that was kind of the environment then. And sort of like not quoting references, I don't know whether he was allowed to do that or not. But he seemed to got away with it. But it would have been good to know what he was working from. So had he read Lorenzi's paper on the Lorentz transformations, you don't know.
About his wife, I mean, we have much more recent example. Yeah. You all know about Jocelyn Bell-Burnell, who discovered pulsars when she was a PhD student in Cambridge. Yeah. And her supervisor took all the credit for it and got Nobel Prize. Yeah. And I know Jocelyn quite well. Yeah. And whenever now she goes to a conference, everybody comes up with the question, Jocelyn, how does it feel to be deprived of something which is your work? And she's extremely gracious, and she said the times were different, and she cuts off discussion. And the guy who actually stole her work has had time, because every time he went to the conference, people were saying, why did you steal her work?
Yeah.
Can I say he didn't steal her work? Yeah. He built the apparatus. Yeah. She actually was put on looking at things in the apparatus. She
was also building the apparatus with her husband to become.
And that's not stealing the work. What she should have been. She was on the paper, and 3 or 4 other people were on the paper, because they contributed to things. People who built the apparatus in CERN get credited with the discovery of Higgs as much as the people who do the experiments.
So why didn't everybody on this paper got Nobel Prize?
Well, they don't. That's what's unfair.
Yeah.
What's unfair isn't what's on the paper. What's unfair is the Nobel Prize.
Yeah.
And there's been a lot of cases where one author has got it and other people haven't.
Yeah.
They usually give it to the more senior people. I mean, there were hundreds of people involved in several CERN discoveries, thousands, and only one or two people got Nobel Prizes. They probably didn't even make the crucial observation. That's the way they do it. I don't agree with it, but that's the way they do it. They don't give it collectively, except for a small number of people too.
Yeah.
Roger, do you still want to comment, or anybody from Zoom want to comment?
Yeah, the Nobel Prize system needs sort of revising, really, doesn't it? Because they don't have a Nobel Prize for mathematics. It's sort of it distorts things.
For mathematics, which isn't the Nobel Prize.
Yeah.
You've got to be on
Fields.
to get it.
Fields medal.
So you've got no hope if you're over 40.
Yeah.
Like Andrew Wiles.
Yeah.
Oh, really?
Yeah, he was over 40, so he couldn't get the equivalent prize. Fields medal.
Fields medal, yeah.
He couldn't get it.
Yeah. It's always distorted.
Only marginally.
Marginally distorted.
Okay, have we come to the end of discussion? Or you want to say something?
Yeah, possibly.
Sure.
I'd be interested in that reference to the curved Newtonian space, if you could send it to me, Roger.
Okay.
In addition to that, I mean, I think the culprit here isn't Einstein or anybody else. The culprit here is Eddington. Because he distorted the whole concept of what relativity. He created all this revolutionary relativity theory.
Yeah.
And that's the problem here.
Yeah.
I don't think it's anything to do with Einstein.
Yeah,
He just published papers as he did, and other people have made it into something other than what he intended it to be.
Yeah, there was also a thing that after 1919, when people were criticising relativity, was the academics. If you were criticising, you were dismissed as not understanding it, and there was only 12 people who understood the theory. So it's sort of elitism.
I think so.
Okay. Yep. Go on.
A very little thing, Roger. It's just very interesting translation. Let's say German to English. So I just noticed the title. So electrodynamic.
Sorry, you're distorted. I'm finding it hard.
I'll come. If I come up here,
Yeah.
you can hear me. So I'm saying in the German, the name of the paper is zur Elektrodynamik der bewegte Körper. In English, it's on the electrodynamics of moving bodies.
Yeah.
Now, the German is bewegte, which means moved, and the English is moving.
Yeah.
Now, that is actually, it is actually significant, but it's not, so translation is betrayal, as they say. That's all.
I have a question.
Yeah. There's a lot of things you
wrote a very influential book about general relativity, right? And most people who study general relativity have read his book. Do you think that gave an accurate picture?
Which book was that?
To many people, I would think it did.
Sorry, Louis, what book are you talking about? What book was that?
The Meaning of Relativity by Albert Einstein.
Yeah.
University Press. It's gone through 5 or 6 editions.
Yeah.
Very well-known book.
Yeah.
Einstein and approved by Einstein.
But it could have been that he wasn't thinking that way in 1905.
Yeah.
Well, this is how he was thinking by 1920.
Maybe we all do that. We publish a paper and then we get a better idea of what it is about. That's right.
But that's why I say, I think that most, if you read modern accounts of relativity, they're all more or less in line with Einstein's meaning of relativity.
Yeah. But it's not in line with the 1905 in my interpretation.
Well, I'm not sure of that, because I think that there were some extra bits added by Sommerfeld. But if you look at the original, then also what was made more clear in the explanation by Sommerfeld is there also implied in the German version. He was not talking about Euclidean geometries at the time. So what he's talking about is he's talking about a place where one can look at that as being close to that, and that's implied also in the German statement. So I'm not sure that it holds water that Einstein's original theory was just Newtonian.
And also, a lot of people come up with nonsense about Einstein's theory. Einstein never said this twin paradox. He never said each twin will see the other as aged. He never said that. He said one will see, the one that group will see the other as aged. And he didn't say each will. Well, that's an interpretation that's come through use of the word relativity.
There's a lot of interpretation problems with what Einstein's saying.
Serious problem. Using that word, so it's all relative, and it's not relative. It's about invariance.
Yeah.
It's nothing to do with relative.
Yeah. Yeah. So, some people say that calling it Einstein's relativity theory is a misnomer. So it's really an invariant theory.
But I mean, he never had this twin paradox. That comes after.
Yeah, there was another person who wrote on that one there about 1911 or something. So Einstein wasn't the only person working on relativity. He had other people talking about relativity, and I think they changed it from what he was originally saying in 1905. And it's not really clear how that came about. It's not really don't have a proper historical record of what's going on there, and you also don't have a proper historical record of what Einstein is working from. You don't. It's sort of like there's too many gaps.
Not the maths have been done anyway. Yeah, that's right. Lawrence has already done math and other people.
Yeah.
Quite a few people contribute to the Lawrence.
But Roger, that's quite a normal kind of thing to do. If I look at, I'm going to be presenting some stuff on my theory later today, and it's also still a work in progress.
Yeah.
Of course, what one talks to people, I know there are many different ways that it could, some of the signs, especially, that it could go one sign or another sign.
Mm-hmm.
So and that remains a work in progress. So if I look at the 2014 version of the theory and compare it to 2019, there was quite a lot of change. And then in the 2023 version, there's not really so much change. So hopefully it's converging. It remains a work in progress.
If you're talking about quantum physics, it's sort of like relativity, what they did in relativity influenced the way they were thinking in quantum physics as well. So it's all just to carry on.
Yes, it's for all of us. We're all.
Yeah, it's all work in progress.
That's right.
Yeah.
Best done through this kind of thing, talking to people. So.
But when you come to actually do an experiment, you want the theory to be precisely defined, so you can then test that particular prediction. But if the theory is a work, if the theory is a working development, and you do an experiment and they don't quite agree, and then you're adjusting the theory a bit, and you still say, yeah, it's the theory, it's still the same theory, and that's cheating, that's moving goalposts. It's the mental attitude. Are you working from a clearly, precisely defined theory, or are you working from a theory that's going to be modified?
Precisely defined. Look at quantum theory now, how precise is that?
Yeah.
Yeah. But Frank Cox had an interesting one on the Michelson-Morley experiment. He says, why didn't they discover the ether, as it were? Why didn't they discover a change in velocity? He says it's because the boson is a massive particle. The boson involved in the interaction is a massive particle. Had they been doing a weak interaction or something, it wouldn't have been that. It would have been the weak or Z boson.
Yeah.
Well, it's interesting how Einstein changed his view over his lifetime. Well, he could actually did at the end of it, and called it different things. I think he ended up calling it universal fields.
Well, the reason why he didn't call it ether was because that had acquired Nazi connotations through the Nazi scientific in the 1930s. And he stopped. He used to call it ether, and then he stopped calling it.
Yeah, there was a period he was calling it ether. His name is beautiful on this Polish author. His name is
Silvers.
No, it's not Silvers. I'll look it up.
Yeah. So a lot of the ether problem goes.
Yes, Costro's a friend. Yeah, he's a really great guy.
Fantastic.
Wonderful.
Yes.
May I suggest that we have comfort break before John lectures?
Oh, I'll break.
You can chat
I'll break.
Roger if you want.
I'll break. What's to say for me?
I'm sorry.
One more.
One more question.
One more question.
I want to make a little comment regarding the German language. I think there is a misunderstanding which is easily possible. If Einstein says it's about über die Elektrodynamik von bewegten Körpern, one could mean that this means that it is an object which is moved from the outside. It would be logical if it would be this way, but the German language means it in a different way. Bewegte Körper does not mean that somebody had set it to motion, but only that it is in motion, nothing else. I think that was perhaps not correctly understood, but it is, I think, a deficiency of the German language that you can have this misunderstanding. So it is a moving body, what Einstein has meant.
Thank you so much. I think any more questions or remarks, please contact Roger, because I'm sure he will be happy to reply.
Okay.
Okay, 10 minutes break. Thank you, Roger.
Thank you. Cheers. Bye. Thank you. So
I think, Roger, you can unshare your